Ever wondered how a powerful three-phase electric motor is made? From raw materials to a fully assembled machine, today we take you inside a local factory where skilled workers bring these motors to life, by hand. Let's dive into the fascinating process of electric motor manufacturing. Before an electric motor can power machines, it needs a strong and durable body. And that's where the casting process begins. In this local factory, workers use traditional casting methods to shape the motor housing by hand. It's a process that requires precision, experience, and a deep understanding of materials. Let's take a closer look. Every great motor starts with a well-made mold. Here, workers carefully shape the casting molds using fine sand and binding agents. These molds act as a negative impression of the motor body, ensuring the right shape and size. This step is crucial. Any flaw in the mold can lead to defects in the final motor housing. That's why workers take their time to get it just right. Now comes the most intense part, melting the metal. In high-temperature furnaces, raw metal, often a mix of iron and aluminum, is heated to extreme temperatures until it turns into a glowing liquid. This molten metal must be handled with extreme care. One small mistake could lead to spills, burns, or defects in the final product. Once the metal reaches the right temperature, it's time for the pouring process. Workers carefully transfer the molten metal into the molds, filling every corner and crevice. This step requires a steady hand and precision. Too little metal, and the casting won't be strong enough. Too much, and it could cause cracks or deformities. Now, we wait. As the metal cools, it slowly solidifies into the exact shape of the motor housing. This cooling process can take minutes or even hours, depending on the size and thickness of the casting. During this time, the metal structure strengthens, ensuring the motor can withstand heavy loads and intense conditions once it's in use. Once the metal has completely hardened, it's time to break open the mold. This moment reveals the first look at the motor's new body. But it's not done yet. Fresh castings often have rough edges, extra material, or minor imperfections. That's why the next step is just as important, trimming and finishing. The freshly cast motor housing now goes through a cleaning and finishing process. Workers use grinders, polishers, and hand tools to remove any rough spots or excess metal. This ensures a smooth and precise fit for the motor's internal components. Without this step, even a small defect could cause misalignment or inefficiency in the final motor. Before moving to the assembly stage, every motor casing undergoes a thorough quality check. Workers inspect each piece for cracks, weak spots, or imperfections that could affect the motor's performance. Only the best quality castings make it to the next stage, ensuring the final motor is strong, durable, and built to last. And that's how the casting process brings an electric motor's body to life. From sand molds and molten metal to a solid, polished housing, this is the first and most critical step in motor manufacturing. With the motor body cast and finished, it's time to bring this machine to life. Now begins the assembly process, where each component is carefully fitted to ensure smooth performance. This stage requires precision and expertise. Even a small misalignment could affect the motor's efficiency. Let's see how it's done. The stator is the heart of an electric motor. It generates the magnetic field that drives the rotor. Workers carefully fit the stator inside the motor housing, ensuring a snug and secure placement. This part is critical because any loose fitting can lead to vibrations, noise, and inefficiency in the final motor. Next, the rotor is installed. This is the rotating part of the motor, responsible for converting electrical energy into mechanical motion. The rotor must be perfectly centered to avoid imbalance and friction. Skilled workers carefully position it, ensuring it spins freely and smoothly inside the stator. To keep the rotor moving efficiently, high-quality bearings are installed on both ends. These bearings reduce friction, allowing the rotor to spin with minimal resistance. Once the bearings are in place, the end covers are secured, sealing the motor's internal components and ensuring stability. Now comes the electrical wiring. Skilled workers carefully connect the stator windings to the motor terminals, ensuring a secure and reliable connection. This step is crucial. Proper wiring ensures the motor receives the right voltage and operates safely under load. Before moving on to testing, workers perform final checks and adjustments. Every bolt is tightened, every connection is secured, ensuring the motor is built to last. And with that, the assembly process is complete. The motor is now fully built and ready for testing. But before it's put to use, it must pass strict quality checks to ensure smooth operation. At the heart of every electric motor lies its copper windings, the key to generating electromagnetic fields that drive the motor's rotation. The rewinding process is one of the most critical steps in motor manufacturing, ensuring the motor delivers efficient power and durability. Let's take a closer look. Before winding begins, the stator core is prepared. Workers carefully insert insulation materials into the stator slots to protect the copper wires from short circuits and overheating. Proper insulation is crucial for motor longevity and safety, ensuring smooth operation under high electrical loads. Now, the most precise and delicate step, winding the copper coils. Workers carefully wrap thin copper wires around the stator in a precise pattern, ensuring the correct number of turns and tension. This determines the voltage, power, and efficiency of the final motor. Some factories use automated winding machines, while others rely on skilled workers to hand wind each stator with precision. Once the windings are in place, they must be secured and aligned. Any misalignment could cause vibration, heat buildup, or energy loss when the motor is running. Workers use special tools and techniques to keep the coils neatly arranged, ensuring maximum efficiency and durability. To protect the copper windings, a high-temperature insulating varnish is applied. This strengthens the coils, prevents movement, and shields them from moisture and heat damage. The stator is then placed in an oven for curing, ensuring the varnish fully hardens and provides long-term protection. Before moving to the next stage, the newly wound stators undergo rigorous electrical testing. Workers check for proper resistance, connectivity, and insulation strength, ensuring every winding meets the required performance standards before final assembly. And that's how a motor gets its powerful copper windings. This precise and delicate process ensures the motor can operate efficiently and reliably for years to come. Now, it's time for final assembly and testing. With the motor body cast, the stator wound, and all major components ready, it's time for final assembly. In this stage, workers carefully bring all parts together, ensuring perfect alignment and precision to create a powerful, efficient electric motor. The rotor is carefully inserted into the stator. This is the part that will spin at high speeds, converting electrical energy into mechanical motion. To ensure smooth operation, it must be perfectly aligned. Even the slightest misalignment can lead to noise, vibration, and reduced efficiency. Next, the bearings and end covers are installed. Bearings play a crucial role in reducing friction and ensuring smooth rotation. The end covers seal the motor, protecting the internal components from dust, moisture, and external damage. Now, the motor's electrical connections are completed. Skilled workers carefully wire the terminal box, ensuring all connections are secure and properly insulated. This step is critical to ensure the motor receives the correct voltage and functions safely under various operating conditions. Before the motor is approved for use, it must pass a series of rigorous tests. Workers place the motor on a test bench to check voltage and current levels, rotation speed and balance, noise and vibration levels, temperature and insulation strength. Only motors that pass these strict quality checks move to the final stage. With testing complete, the motor is now ready for clouting, the final finishing and packaging process. First, the motor is painted to protect against corrosion and wear. Then, a nameplate is attached, displaying key specifications like power, voltage, and speed. Finally, the motor is carefully packed and prepared for delivery, ensuring it reaches customers in perfect condition. And just like that, a new electric motor is born. From raw materials to precision assembly, testing, and packaging, each motor goes through a meticulous process to ensure high performance and reliability. If you enjoyed this behind-the-scenes look at motor manufacturing, hit like and subscribe to King Discovery. Stay tuned for more fascinating videos on how things are made.